Okay, so I hope this time they will be displayed more clear, right? Can you guys see it?
Yes.
Yes. I'm a basic emitter.
Yeah. Okay, just a minute. Okay, the first thing which will be start with the common admitter. Okay, the first thing they want you to build the circuitry. Okay, so in order to get the job done, first thing you have to build correctly. And you understand in here. Okay, so this is the generator. They will be connect, go to that one. That means CE. If they connect, go down to the other side, they will be CB. So for the first block, they can be testing for CE amplifier and the CB amplifier. Okay, so now first thing, make sure we make the correction for build the circuitry the way they want it. So the first thing you connect the power. And now that will be go to the CE amplifier. Okay. And 1, 2, what else do we need? You have to tell me. Is it correct with the circuitry they wanted or not? you can see the circuitry they wanted. I'm not talking about generator right now, but we're talking about building the circuitry. What missing?
I think bypass capacitor.
No, we don't have a bypass capacitor.
You're not talking about the generator, right? You're excluding.
Yeah, we're not talking about that. Right now, we're just talking about build correctly.
You need the DC power supply.
We already done, right? DC connector, DC power supply.
Everything looks good.
Yeah, everything looks fine.
Maybe R dot.
You compare between two circuitry, telling me which one we're missing.
VB.
Which
I
one?
don't see anything missing. You got the connection to the DC.
You
You
don't
got the
see any
C1
missing.
connected.
Who can tell me the missing?
The VB.
Hey, Mr.
One.
I know they're still missing.
Yes.
Which one?
The VB.
VB.
Yes. Right there. Right there.
Nothing. Nothing missing.
Okay.
You can see right here. They connect in here. They connect to go directly to the base. But I said still missing.
Okay, Mr. Pham,
Yeah.
did you want the capacitor C3 hooked up?
C2, C3. Yeah, they already hook it up.
No, there's a dashed line between the, like if you go straight down, a little bit more, right there. There's a dashed line right there.
That will be telling you right here, right?
We don't have that. That's not part of the circuit.
Yeah, that's R6. That's not in this one. Everything looks correct. What are you
Oh,
missing?
yeah. Yeah, that's R6. I'm sorry, go ahead.
Everything looks correct.
Okay, it's right now, right? Okay, so see what they want you to do. Okay. So basically, they will be doing calculation and measurement for the DC voltage. That means they have to calculate the VB or VE or VC. Okay. And basically, we already get through it. VB means voltage divider. The voltage here, they're telling you to adjust it into 15 volt. And 15 times R joule divide R1 plus R joule. Okay. And after you get VB, you want to get a VE. You take VB minus 0.7 volt for the silicon. And if you want to calculate the VC, you take VCC minus IC times RC. Okay. So that we already done. I don't want to go. Okay. we want to go to the next one. Okay. Now, I don't do anything on the DC, okay? That's a very simple thing. You can using the DMM to measure the DC voltage here, measure here, and measure here. You can get VB, VE, and VC. So any DC measurement, you get any question?
Aren't you supposed to measure your DC input?
Yeah, that's what, basically, I skipped that from the beginning. They will be telling you measure the VB. So basically, you want to measure the VB, connect the high side to the base, low side to the route. Okay? Then they want to measure the VE, same thing, connect the high side meter to here and the low side to the route.
Hey, Mr. Pham, and for VC, since you have that that broken line over there where R6 at, it won't measure that area. It'll just go past R5. Is that correct?
Now the thing they did for AC setup.
Yeah. I'm
for
saying,
DC,
yeah, I'm saying when you measure VC, it won't measure that part, right?
VC, they don't care here. The thing is, C3 here is DC blocking.
Yeah.
Okay,
But you still use that point to measure VC.
right here.
Yeah. Thank you.
You're welcome.
Technically, right now, technically the circuit's not, or the transistor's not powered on, correct?
They power it on.
All right, so other than trying to measure, we just need to do a DM on the power supply for DC input to make sure it's correct voltage.
Right. Normally at the beginning, they asking for power supply here will be 15 volt. So basically you connect the high DM high here, DMM low here, right? If it's not 15 volt, you have to adjust the positive voltage to make sure you get 15 volt. That's on the process. When you do it, they telling you how to do it. But the thing is, they say to me, that is so simple. Only thing is, if you get any question regarding to the DC measurement, then I can tell you.
What if you had a negative DC, more negative DC than you had positive DC? What effect? There won't be any effect in the circuit, just your measurements at each component will either be positive or negative, correct?
Now, depending on circuitry,
Right.
for this circuitry, they must be positive.
Right. So that's because of the direction of the arrow and the transistor and how the current is supposed to flow
Right,
to ground.
right. That means the current IB go this way. Okay, current IC going down, current IE going down. The power supply must be blood 15 volt. And now they just want you to using the meter to measure voltage at the base, voltage at the ammeter, voltage at the collector. If you get any question regarding to the DC measurement, just go ahead and ask, okay? I suppose your guy can get it done quickly. Okay, any question? You understand on this the CEMD5, that means the generator will be applied to the base and the output from the collector. Okay, only thing is the input and output will be our phase, 180-degree out phase. So right now we go up to the AC part. We have to following that schematic to see you make a right connection or not. This one compared to this AC for this one. What we need to do.
It's like you need to connect R6 to
Connect
C3
your
or C3.
R6, correct. You see that? Okay, if you see it, you can see they get a broken right here. Right? These are broken R6. However, in the circuitry, they connect through R6, correct? So you have to connect that. Now I can connect this one. Okay, so that's the complete setup, the circuitry for the AC. Okay, any question? If it's not, we see what they wanted to do. They say why observe signal on scope channel 1. Adjust the sine wave generator for 1 kilohertz, 300 millivolt peak to peak. Okay, at the base. So now the generator will be connected to the generator here. Okay. And the big problem in here. Okay. That will be telling you. I go back to the generator to talking about the generator first. Okay, this is the generator. So what I want, 300 millivolt. Okay, first thing I'm telling you, you have to turn generator amplitude counterclockwise to the minimum. Okay, to see how much voltage you're able to get. So you turn it, generator, okay, to the minimum. Auto set, measure to see what you get. Okay, what the voltage you get? Let's see, I can see or not. What the voltage? Peak to peak.
2.1 volts.
You're looking on the oscilloscope telling me. channel 1, pick to pick.
He was right, Mr. Pham. That's what it says, 2.1.
Okay, 2.1. 2.1 volt. That is the minimum generator can give it to you. You cannot get more than 2.1 volt. So if you want to go smaller, what can we do?
There's an adjustment that you have to make on the generator itself.
That's what I did it. I go to the minimum and they given to me 2.1. I want to smaller than that 2.1. What can we do?
Go to the attenuator.
You can use the attenuator, you can pull out
Yeah,
Look up
that's
the-
right. That's
Look up
right.
look up the attenuator into the input of the generator.
just pull out the amplitude switch and you can, that'll reduce it, or the attenuator. 300 you can get on the, just pulling out the amplitude.
So basically you need to get the minus 20 dB right now, correct? You have to get to the minus 20 dB in order to do it. If you're looking on the generator amplitude, they put a minus 20 dB.
Hey, Mr. Pham, if you want to show the class that you gotta lift up you can't see the right side and the bottom of your generator where you would make that adjustment if you want to show the class on Zoom.
Okay.
No, the other way.
Now I try to see.
Just go up a little more and then to the
Yeah,
left.
wait a minute.
We can see it now, just if you just pull out the amplitude switch.
You see the amplitude, right?
Yeah, we
Yes,
can, yeah, we
You
can see it.
it.
Yeah,
It is the amplitude here.
yeah, we see it now.
Okay, if you're looking at the bottom, they get minus 20 dB. Put it out. Okay, so you can pull it out. You can see that.
Yes, yes.
So what's the voltage right now?
It's 300 millivolts.
That's around 300 millivolts.
Yeah, that's what you want. That's correct.
Okay, so basically, this is the voltage you're able to accept it. Now, I get another question. If I want 100 millivolt peak to peak, what can we do? Either 100 millivolt or 50 millivolt peak to peak. Generator cannot do it.
Are you saying you need to adjust your circuit for some type of voltage divider or something?
Somehow. Okay? You're
You run-
telling me, if I
run
want
the-
100 millivolt,
You
peak to
run
peak,
the generator inputs through the attenuator and then the outputs in.
exactly. Okay. This is generator, the same with the other different generator. They get the same way. If you want a smaller voltage, you can get the minus 20 dB button.
Mr. Pham,
Yeah,
what's more precise, the generator attenuator or the circuit attenuator on the lab volt board?
exactly. I will be show you.
All right, thank you.
Okay, so now only thing I bring it up. If you want 100 millivolt peak to peak or 50 millivolt peak to peak, and now no matter what, generator cannot do it. When you already pull the 20 dB, and they only think they give it to you in here, so mean you can get around 300 millivolt peak to peak. Okay, so if you want more, I show you how to do. For example, 100 millivolt. Okay. Then now you're looking into the circuit board. Okay. And you can see in here what they call a attenuator. See that?
Yeah, there you go, yeah.
That means a voltage divider. The thing is when they design the left volt, they already know. Generator cannot give to you 100 millivolt peak to peak or 150 millivolt or 200 millivolt. So that's why they're adding this circuitry here. So they will be divided. So now, in order to do it, you connect generator output into in of attenuator. You see that? You connect to in. And the output of generator connect to the generator of the circuitry. And that one here, okay, you connect into the generator output. Okay, so that will be telling you, you connect the generator output to the input of the attenuator, and the output of attenuator connect to generator of your circuit. So in order you can get very small voltage peak to peak, millivolt peak to peak. Okay, so the scope now, I will be connected to the generator. Okay, so if you see, look like, okay, very small voltage. I press auto set, measure. See, cannot see signal. Okay, so I adjust generator. I don't need 20 dB. Auto set, measure. Okay, you can see the signal. Let's see, try to make generator bigger. Okay,
Hey, Mr. Kip Pham, can I ask a question while you're doing that?
just a minute. Okay, what's the question?
Since you set up the lab volt board to do that attenuator thing, did you press the did you push the amplitude button back in?
Okay, so.
No, I'm asking you. I'm asking.
Okay, you connect the generator, that one, right? Generator to the input of attenuator. Okay, you follow that?
Right now, your picture is on the scope and the generators, not on the board or whatever you're doing. Yeah. Okay, so.
That's what I said. This is the output of generator. Okay. This is the output of generator connect to the in of attenuator. You follow that?
Okay, but my question is on the, then on the generator itself, that amplitude knob, did you take and put that, push it back in? Because you said you didn't need 20 dB anymore.
That doesn't matter. You need it or you don't need it.
So you leave it in or leave it out? That's what I'm
I
asking.
leave it out so
Okay,
I can display the signal for you to see.
okay, thank you.
Okay, now, after I connect generator output to the attenuator E, okay, and also attenuator out right here, connect to your generator of the circuit, and also connect the scope channel 1. You get that? Okay, any question about this connection? Again, the reason we have to using attenuator, the thing a generator cannot give you small voltage. So we need a divider in the circuit board.
Will the lower resistor be a smaller value range wise than the 300 millivolt input?
Now that depends. Right now, you connect in and you connect out. The first one is not working, you can connect to the second one. They get two input, two out. Either one. Different value of resistor, different divider. Doesn't matter. You want the voltage you want it. So right now, I just asking about connection. Otherwise, we're going back to the scope. Right now, what the voltage on the scope? You just make the generator any voltage you want. Make it bigger or smaller. Okay? We will be adjusted. Now, how many voltage right now? 800.
About 80, 840 millivolts.
Okay,
So you need to adjust it down.
exactly. I will be adjusted down. I want 100 millivolt.
100 or 300?
Now 100. 300, you don't need that attenuator. Right? 300, you don't need that attenuator. Right now, I'm talking about 100. I just tried to show you how to using generator with very small voltage. So I try to adjust it going down to 3 millivolt. So right now, what the voltage? $256. You can see that. Then now you try to go to 100. Okay, that is the maximum output of generator. So they still cannot make you 100 millivolt peak to peak. Then you need to pull it out 20 minus 20 dB. I pull it out. See that signal. Try auto set measure. See, that means the signal is too small. I try to increase the generator. Okay, auto set measure. This is the signal. Okay, what the scope telling you? How many?
It measured, Mr. Fran.
Okay, auto set measure. What they measure?
Average of about 300.
Okay. You want 100. So you have to going down. Okay. So generator going down. Okay. What they get?
150.
Okay. Now I can tell you one thing. When the signal in the millivolt, the scope cannot measure exactly the value. Okay. Don't search on that number. What can we do now?
Try and go average to allow the processor of the oscilloscope to condense the signal.
No, cannot.
Use cursor to measure.
Exactly. In this case, you don't search, automatic measure anymore. You must be using the cursor. Okay, the signal too much noisy. So scope measure will be wrong. So in order to do, first thing,
Would you, would you adjust the trigger at all?
what do you mean a trigger? That is already display the signal. You can see it.
As stable as possible.
The thing is, any trigger, they not make any difference. Okay. The thing that you see, the signal is too much noise. So that's what I said. In order to get the value, you must be using cursor. Okay. Now, first thing you press the cursor, and will be measure the voltage. Okay, so you move that one cursor to the top, and move the second one in the valley. Okay, what delta equal?
$64.
64 millivolt. Okay, however, you want what? You want 100 millivolt, and now you increase generator voltage. If they want 50 millivolt, you have to also adjust the generator. So I can increase the voltage of the generator here. Okay. Then I try using the cursor to measure again on the top and on the valley. They given you the value, delta 140. Then you have to adjust generator going a little down. Okay, and adjust the cursor. Okay, that will be 100 millivolt. So again, if they need a small voltage, then generator cannot do it. You must be connected generator output to attenuator. Okay, to attenuator circuitry. Then connect output of the attenuator into your circuitry. Okay, and try to adjust the generator to get the voltage you wanted. However, this is very small voltage, a lot of noise. Oscilloscope cannot measure correctly. Then you must be using the cursor to adjust it.
Question, Mr. Friend.
Okay, any question, anything?
Yes, so I know that using the CPU or the processor of the oscilloscope can assist with clearing the signal, make it as clean as possible.
No,
That's it. That's not advisable in all situations.
you have to pay more. Hopefully, scope can do it for you. But scope normally for a small voltage, they can measure not correctly. So that's why I tell you, you have to be using the cursor. Okay, the thing
Well,
is, you see, the big noise, the scope will be measured from the top to the bottom. That will be wrong.
Will the input frequency cause more noise
No,
with the average processor? Wouldn't there be like a clock issue maybe?
no, I don't think so. Maybe, however, depending on the frequency, okay? However, no matter what, when you wanted to see too much noisy, then you must be using cursor. No choice. Okay, so by the way, at this time right now, we're going back to the circuitry. We want 300 millivolt. So I adjusted to 300 millivolt. So I increase generator. Okay. I try auto set measure to see what happened. Okay, auto set measure. Okay, let's see what they telling you, what the voltage right now. Around 3, right? However, you can see the signal is still noisy. So you must be using the cursor. Okay, press the cursor. Okay, cursor, measure the voltage. I move to the top. And this one move to the valley here. They say 100 millivolt. Increase generator. Okay, and try move to the top, move to the valley here. That's a 300 millivolt. This is the key point for the guy to get the lab done.
Question, Mr. Friend.
Yeah, go ahead.
Right now, we're just measuring AC voltage with the cursor and making the adjustment for the noise. Just a general technical tool question. If I was to use a tool, would I have a problem, or would my noise clear the signal if I were to put a capacitor in line?
No, you can try to put a capacitor. Okay, maybe they fill it out, but I don't think so. However, when you do a level, you cannot put anything. Only thing for your own design the circuitry. But when you see the signal is not clear on the oscilloscope, then don't using the automatic measurement. You must be using the cursor. That's the key point for the guy to get the lab done. Okay, so now we already done one signal, 1 kilohertz, 300 millivolt, peak to peak. Okay, and try to see what next they want. Okay, they connect the scope channel 2 to the output, and they want to measure the Vout. So I using channel 2. Okay, this is the channel 2. Connect to the output here. Okay, and the route will be tied to the route. Okay, now I turn on channel 2. Okay, so you can see channel 2. Now you can see here. Okay, automatic measure.
For the channel 2 output, is the cleaner signal a result of that capacitor, or
Now the thing is bigger voltage.
it's more stable? All right, thank you.
When you get a very small voltage, you get the noise. So you can see the difference between signal on channel 1 and channel 2. Okay, so basically there will be a 180 degree out phase. Okay, the question is in phase 180 out phase. They will be out phase. Okay, and then they given to you, okay, AC output, okay, and they want to calculate the gain. Okay, so that's what you need to do. That's the same thing. You just do calculation. I'm not doing it on this one. Connect channel 2. Scope to the admitter terminal. Okay. So now I connect channel 2 here into admitter. Okay, so now you can see. Okay, that two signals. They will be in phase. Let's see if I automatic measure to see what you can see. Okay, so basically the signal when they go into the base, and then they will be go to the admitter. Okay, and they be in phase. You can see either both go up or both going down. So if you're looking into the circuitry here, okay, so you can see that the voltage at the base, and they will be go into the admitter. So no bypass capacitor here. So that's why you can get the same voltage like the base. So the answer here will be the same at the base, will be 300 millivolt. Okay, let's see what else. Question in phase or phase, they will be in phase. Connect channel 1 probe to the input B terminal. Connect to the channel 2 to the output. See what else they want. Okay. They say slowly increase the AC input until the value of the, we still get another one. Okay, increase the AC input signal until the peak of the AC output signal stack become flip. Okay, so now I increase the voltage AC generator. Auto set measure. They still okay. Keep increase. auto set measure. Okay. Okay, so basically, you want to increase more. You don't need a attenuator. I want to increase more voltage. So I take the output of generator, okay, and connect into the generator. And you can see the signal. Okay, let's see, auto set measure. Let's see, generator now connect into the generator. Okay. And we try to increase let's see. Oh, sorry. Connect output into the output here. Okay. So now you can see the output. They cut it on the top. So what happened to the transistor right now?
Fully saturated.
They will be saturated. Okay. That means they don't have any more gate. So I will be go to that later, telling you on that circuitry. Okay, when they see the signal, they cut it either on the top or on the bottom. That means they be saturated or they will be cut off. then no more amplifier. Okay. That means in the amplifier, they can using the formula IC equal beta times IB. However, if they saturate it, you cannot using this formula. Okay. So in here, they can ask you what point on the AC load line is reached. Okay. So basically reach it to the maximum. And I believe the answer will be the cutoff point. However, for A, B, C, D, if A is not okay, then you can get B, or you cannot, you get C. Okay, this doesn't matter to me. You want to understand, then you have to go into the website, go to the left vote, and that will be all of the information when you do your lab. You have to go through it. Okay.
That's just the effect of the a resistor value, correct? If I would,
Basically, to try to apply too much voltage at the base, forcing the transistor go into the saturation. Okay. And now, in the second one, they can see at the bottom, the valley, they will be cut it off also. Okay. So that will be saturated. And later they explain to you whatever. You have to read it. Okay. That no more. Now, I will be go into the one. Try to explain to you something. Okay, let's see. Coming collector coming back. Okay, now I'm going to explain to you something here. Okay, so basically they're telling you common add meter. So input apply to the base. Okay. Output from the collector. This capacitor will be DC blocking or AC coupling. Okay. That means they allow sideways to go into the base, and the DC will be blocking. And they're telling you input, output out of phase. Input go up, output going down. Input down, output going up. Okay, so after the bare at meter voltage up about 0.6 volt, the bare current will be increment. Okay, and now you can see on that one, this is load line. Okay, so you see that will be stand for current IB. Okay, IB. IB. Okay, that stands for VCE. Okay, VCE, and that one stands for IE. This is the Q point. Okay, that means the Q at the Q point, you're able to know what VCE equal. You can going down. You can get the value of VCE. You go to the left, you get the value for current IE. Okay, and this is the saturation area, and the current I C equal saturation at this point. And this is the voltage VCE for the cutoff. Okay, so that the VCE on this line, IC equal 0. On this line for IC, VCE equal 0. So this is the Q point. Q point can moving up to the saturation, or they can moving down to the cutoff. Basically, that's for engineering. When they design the circuitry, they want to be saturated or they want to be amplifier. That will be telling you how to calculate the VB here, okay? And they can give it to you. Data ABCD, when you do it, you can get that one. For example, component meter, transistor, amplifier, circuit head, high current voltage, power, high input, output impedance, all of the above, none of the above. What do you think? Okay, telling me what A, B, or C, or D. Can you hear me?
Yes.
Based off your recent example, we were
Let's
pretty low
see.
with our voltage.
Answer C.
A.
C.
Okay, that's what I said. You have to telling me, okay? You understand me? You want more output voltage or current or power, then you must be using CE amplifier. You get CE, CB, CC. Only that one will be given you high current. And also they get a high input output impedance. So the answer will be C. I just quickly go through it, okay? And if you get a question, just let me know. Okay, so that one, we already done it. Everything here. Okay, you can see that if you're reading this material in the left vote in the website, they already given telling you again, how do we calculate the VB? Okay, And that question, we don't go to the question. And now if you want to calculate the VE, VE equal VB minus 0.6. Current IE, you take VE divide R5. Okay, that's just a question. Okay, also they given you more explanation on the DC load line.
So when looking at a signal in general understanding, we want to see the scope signal that's displayed right now. That'll pretty much tell you if you have a saturated transistor versus a resistor that might be out of tolerance.
That means you're forcing the transistor to the saturation or to the cutoff.
So in order to try and get the exact signal that you want, always verify the resistors first to make sure they're in tolerance.
Now that doesn't matter. That not make a difference. They just telling you to increase the voltage of the generator until they will be flat on the top or flat at the bottom. And they asking you just a multiple choice. Okay. I just go into here. Okay. Okay, and I just quickly go to here and try to see what they're telling you to do calculation. Do they measure the voltage? So now they build in that one here on the DC. Okay, so they want to measure the VA. That means the power voltage. Okay. That means at the output of the DC voltage. And they already telling you they want 15 volt. Okay. Then you can get 15 volt. And then they want to measure the V. We don't need the scope anymore. So that will be make easy for you guys to see. Okay. And now they want measure VB. Just a measure. Okay. Then whatever the question here, we don't care. So basically, they want measure VA, VB, VC, VE. Okay. Just to measure the voltage here. Calculate the correct current. So basically, you have to do in calculation. You take the VC divide of VC, VR, VR4 divide R4. Just a calculation. Okay, so in here, the Q point, that's the intersection of the IC and the VCE. So at this point, Q point here, if you want to know IC, you go right here. VCE, this the VCE, almost 15 volt. See that? They're asking you here. You can answer that. Okay, now, what happened when you see the CM? That on it, they want for you to redo it again. They will be changing something here, like changing R1. And they want to make sure you know how to measure the VB, VE, VC, okay? Whenever you see CM7, they just change a little thing in the circuitry and make sure you're able to do the job. Just redo it anyway. Okay? In here, that's just for you guys to read it. They're coming out from the website. Now, they try to see what's going on here. CM again, okay? They just try to make sure you know what to do. If you want to know more in depth, then you can read it. But what I want to do, try to help you to do the lab, not go into everything in the level. You have to read it. That one we already done. That's what I want to talk to you. Okay, we already done it. Okay, so basically they want 1 kilohertz, 300 millivolt at the base. And then they want to measure the output. Okay, so we already helping you. Only thing I want to emphasize here, okay? A lot of people get a problem here. They want a voltage okay, 300 millivolt. It's a small voltage. So less than 300 millivolt, 100 millivolt, 50 millivolt. Then you have to be connect a generator into a alternator in the circuit board and try to adjust the voltage using the cursor to get the voltage you want. Okay, and this one will be a little more when you're going down. They just using CM. That means they changing a few things and try to see, make sure you know how to do what to do. So that will be a complete for the CE amplifier. On this board, you get 5 circuitry. If you know how to do what to do, you can get it done quickly. Okay. Only the difficult thing, if we want a millivolt peak to peak and the scope cannot given to you, I already telling you how to get it. Okay, so any question on the CE amplifier, I can answer you. Okay, so anyway, when you do a left volt at this time, if we have enough circuit board, try to do transistor amplifier. I can go a few more CC amplifier, CB amplifier. And then we have to go into AC transformer coupling or direct coupling amplifier for this circuit board. So any question, anything, I can answer to you.
The CE emitters, most industry standard use.
You mean CE amplify?
Yes, is it used mostly in industry for its
Exactly.
right?
If they want more voltage current gain, then they're using CE. Okay. However, input CE, output CE will be 180 degrees of phase. If you want coming in and a final coming out in phase, then you have to adding another CE amplifier.
Used more in radio signal or in electromechanics, like say a motor? What do you think what is the percentage of its use in order to keep the phase 180 degrees? It sounds like the 180 degrees would allow something to spin more evenly or distributed within the coil.
Yeah, depending on when you're talking about the motor,
Right.
they're going to the right or they're going to the left. Right?
Exactly right.
So depending on, if they need the in phase to go one way or our phase go the other way.
So that's basically in the signal in itself and how we're understanding its phase adjustment. It's kind of like the twisting of a knob going left then right and left and right, like a robot arm in manufacturing, as if the robot arm has to go left and then it has to go back right.
Right,
Similar.
exactly.
Hey, Mr. Pham, can you hear me?
Yeah,
My question is, because you was talking about the lab vote, isn't everybody on different lab vote boards like AC1, AC2, semiconductor or whatever?
okay, for now. Okay. I try to make sure that currently we will be on electronic. So I want to get electronic field circuitry we want to get through. Then we can go with the AC. But AC normally will be running on the summer.
Okay, so I guess what I'm asking is there a specific lab vote board that you want like everybody to work on based on what you just taught today?
Right. That is the first thing I said, okay, you have to do what you do on the transistor amplifier. Next, you do on the op-amp, operational amplifier. Next one, you're doing on the circuitry for active filter.
Okay, so you want us to work on the transistor one, correct?
Yeah, the thing is, however, what I'm saying.
Is that yes or no? Is that correct?
Yeah, yeah. The thing is, we're in electronic. Only thing is, it's not really good. Last semester, we don't have a in-class left volt. So that's why summer they cannot doing anything on AC. Then now, if we run out of the op-amp circuitry or transistor amplifier, then they have to working on AC1 or AC2.
Okay, so right now, the circuit board for the transistor, how many boards do we have? Do we have like, is there like a transistor 1, transistor 2, or are they all the same?
On the
Is there enough of them?
only one transistor amplifier.
Okay, is it enough of them? Because you have like 16 lab spots, correct?
Right, but we don't have a 16 board.
Right.
We get around 9 or 10 or whatever. I don't know. The lab instructor know.
All right.
But we try to maximum. Okay. First
Okay.
thing to do in DC, then you have to do a semiconductor. Semiconductor will be in electronic. Then you can do a transistor amplifier.
But I just wanted to make sure. So right now, you want everybody to, as much as possible, work on the transistor one.
If they know, they have to do DC first, right?
Right.
Okay. then okay, they can start with the transistor amplifier or semiconductor.
Okay, thank you.
If they run out of transistor, they can working on semiconductor.
Yeah, I get what you're saying. If a transistor board is available, work on it. If it's not available, then you have to work on something
Yeah,
else.
if you're following the way I try to help you guys out.
Okay, thank you.
Okay, you understand? I just bought the new thing, so I easy to move my camera and make it very clear to me. Otherwise, in the past, I take too much time to move. Okay, so now supposed to be okay to me. Every lab, like next week, I can get maybe done for CBCC,
Mhm.
and the next day will be done for AC transformer coupling or direct coupling. Then will be done with the transistor amplifier. The other circuit board will not go too much. I think that's not hard to do. Try to get a very, very basic understand thing to do. Then you don't have any problem. Okay, so any more questions, anything? The quiz will be tomorrow, not today. I think that your job will be hand-on. Try to working on left volt. Try to get along with generator, oscilloscope or meter. That is the thing you must be using at work. Circuit board, too many, okay? We just try to make sure you know what's going on, how to do what to do. That'd be fine to me. If you get a question, anything, just text to me. I help you out. Okay, any more questions, anything?
No, thank you, Mr. Pham. Have a good night.
Okay, good night, everyone.
Right.
Good night.
Right.